The Dead Sea, a salt lake bordered by Jordan to the east and Israel and Palestine to the west, is one of the most iconic and mysterious natural wonders of the world. Known for its hypersaline waters, therapeutic mud, and the fact that it sits at the lowest land elevation on Earth, more than 430 meters below sea level, the Dead Sea has been a site of historical, religious, cultural, and ecological significance for thousands of years. However, in recent decades, this ancient body of water has been shrinking at an alarming rate and is now facing serious environmental degradation due to a combination of natural and anthropogenic factors. The most pressing issues threatening the Dead Sea today include water diversion, increased salinity, the formation of dangerous sinkholes, and the impacts of industrial activities. These environmental changes not only endanger the unique ecosystem of the region, but also pose risks to nearby communities, infrastructure, and tourism, which is a significant source of income for the surrounding countries. One of the main reasons for the shrinking of the Dead Sea is the massive diversion of water from the Jordan River, its primary source of inflow. Historically, the Jordan River fed into the Dead Sea, providing it with fresh water from the Sea of Galilee and other tributaries. However, since the 1960s, Israel, Jordan, and Syria have diverted much of the river's flow for agricultural and domestic use. The result has been a dramatic reduction in the amount of water reaching the Dead Sea. Some estimates suggest a drop from over 1.3 billion cubic meters per year to less than 100 million cubic meters annually. This significant reduction in inflow has contributed to a rapid drop in the sea's water level, with current rates of decline estimated at more than 1 meter per year. As the water evaporates and is not replenished, the surface area of the Dead Sea has shrunk dramatically, exposing previously submerged land and altering the landscape in irreversible ways. Another critical environmental issue facing the Dead Sea is increased salinity. While the Dead Sea is naturally one of the saltiest bodies of water in the world, its salinity is over 10 times that of ocean water. The continued drop in water levels has caused the concentration of salts and minerals to rise even further. This hypersalinity has profound implications for the lake's unique chemical composition and biological systems. Although the Dead Sea is largely devoid of macroscopic aquatic life due to its extreme salinity, microbial life, including salt-loving bacteria and archaea, does exist and plays a role in the region's delicate ecological balance. The continued rise in salinity could disrupt these microbial communities and further limit the lake's biological activity. Additionally, changes in mineral concentrations can affect the commercial extraction of minerals like potash, magnesium, and bromine, which are economically significant to companies operating in the region, particularly in Israel and Jordan. Perhaps one of the most dramatic and dangerous consequences of the Dead Sea's shrinkage is the formation of sinkholes. As the water level drops, underground salt layers become exposed to fresh groundwater, which dissolves the salt and leaves behind hollow cavities. These cavities can collapse suddenly, creating large sinkholes that pose serious hazards to infrastructure, agriculture, and human life. In recent years, thousands of sinkholes have appeared around the Dead Sea, swallowing up roads, buildings, date palm groves, and even entire tourist facilities. This unpredictable geologic phenomenon has led to the abandonment of previously thriving tourist areas and has made development in the region increasingly risky. The spread of sinkholes is also a stark reminder of the complex interplay between natural processes and human intervention in altering the region's geophysical stability. Compounding the Dead Sea's environmental problems are the industrial activities carried out along its shores. Both Israel and Jordan operate extensive mineral extraction facilities that harvest valuable compounds from the Dead Sea's brine through evaporation processes. These industries, while economically beneficial, contribute to the depletion of the sea's water and have environmental impacts of their own. The evaporation ponds used in the extraction processes further reduce the volume of water in the lake and alter the natural shoreline. Moreover, the infrastructure required for these operations, including pipelines, factories, and roads, can disrupt local habitats and increase pollution risks. While mineral extraction has long been a cornerstone of regional economic development, it has also become a controversial issue among environmentalists, who argue that sustainable alternatives must be explored to protect the Dead Sea's long-term health. In response to the Dead Sea's worsening condition, several proposals and initiatives have been put forward over the years, the most ambitious of which is the Red Sea-Dead Sea Water Conveyance Project, often referred to as the Red Dead Canal. This project, initiated by Jordan and supported by Israel and the Palestinian Authority, aims to pump water from the Red Sea to the Dead Sea via a pipeline that would also include a desalination plant. The plan envisions using the desalinated water for human consumption, while sending the brine byproduct into the Dead Sea to help stabilize its declining water levels. In theory, this project could address several issues at once. It would provide much-needed drinking water to the arid region, slow the shrinkage of the Dead Sea, and foster regional cooperation. However, the Red Dead project has faced numerous delays, financial constraints, and environmental concerns. Critics argue that introducing Red Sea water into the Dead Sea could have unforeseen chemical consequences, including changes in water color, mineral balance, and potential harm to microbial life. Furthermore, questions remain about the long-term feasibility, sustainability, and geopolitical implications of such a large-scale engineering effort. Aside from large infrastructure projects, environmental advocates stress the importance of integrated water resource management and regional cooperation to address the Dead Sea's crisis. This would involve reducing water diversion from the Jordan River, improving water use efficiency in agriculture, investing in wastewater treatment and reuse, and enhancing public awareness about water conservation. Non-governmental organizations and academic institutions have also played a role in monitoring the health of the Dead Sea, promoting scientific research, and engaging local communities in preservation efforts. There is a growing recognition that any solution must balance ecological integrity, economic interests, and social equity. No easy task in a region marked by political tensions and water scarcity. The Dead Sea's plight is emblematic of the broader environmental challenges facing arid and semi-arid regions around the world. As climate change intensifies and demand for freshwater increases, conflicts over water resources are likely to become more pronounced. The Dead Sea thus serves as both a cautionary tale and a call to action. It highlights the need for urgent, collaborative solutions to preserve natural heritage sites that are not only geologically unique, but also culturally and historically invaluable. The preservation of the Dead Sea is more than a regional concern. It is a global responsibility. If efforts are not made to curb its rapid decline, future generations may only know the Dead Sea through historical records, photographs, and stories. Preserving it will require a concerted commitment from governments, industries, communities, and international stakeholders to recognize the value of natural ecosystems and to act decisively in protecting them from irreversible damage.